A very good morning, my dear students. We have completed our second term portion. Now it's the time for revision for final exams. Today, let's begin the revision for lesson number 14, Measurement and Effects of Heat. Beginning with question number 1, whom should I pair with? Group A, first one, temperature of a healthy human body. So students, the temperature of a healthy human body we know in Celsius is 37 degrees Celsius. Now, it's not given in Celsius. So in Fahrenheit, the correct answer is 98.6 degree Fahrenheit. Second one, boiling point of water. Again, it's given in Fahrenheit. So 212 degree Fahrenheit is the correct answer for boiling point of water. Third one, room temperature. Room temperature is 296 Kelvin. So the room temperature is given in Kelvin. So the correct answer is 296 Kelvin. Freezing point of water. We know students, the freezing point of water in Celsius is 0 degrees Celsius. Moving to the question number 2. You will find if you search. It's fill in the blanks type. First one. A thermometer is used to measure dash. So students, a thermometer is a device which helps to measure the temperature. So the correct answer is temperature. Second one, the apparatus used to measure heat is called a dash. So the apparatus which is used to measure heat is called as calorimeter. So the correct answer is calorimeter. Third one, the heat contained in a substance is the measure of the dash kinetic energy of the atoms in the substance. So students, what does heat content of a substance depends upon? It depends upon the measure of the total kinetic energy of the atoms in the substance. So our correct answer is total. Fourth one, the SI unit of heat is dash and CGS unit is dash. So students, heat has two units. We know in first in SI and second is CGS. So the SI unit of heat is joule and CGS unit is calorie. The answers are joule and calorie. Fifth one, Earth's heat is called as dash. So the answer is geothermal energy. The earth heats is known as geothermal energy. Sixth one, heat always flows from a hotter object to dash. So students, hotter object is known as high temperature. So heat always flows from higher temperature to lower temperature. So the correct answer will be colder object. Heat always flows from a hotter object to colder object. Moving to the next question, question number 3. Nishiganda kept a vessel containing all the ingredients for making tea in a solar cooker. Shivani kept a similar vessel on a stove. Whose tea will be ready first and why? So students, first we will understand the question. What it is saying. Nishiganda is keeping a vessel containing all the ingredients for making tea in a solar cooker. A solar cooker which helps to work by sun's heat, and at the same time Shivani is keeping her vessel on a stove. So whose tea will be ready first and why? So let's see the answer. First point, solar cooker uses heat energy generated in the sun. The sun being far away from the earth, very small amount of heat reaches the earth. Yes students, the sun is very far from the earth and the sun's heat will be used for solar cooker. So, making the process of heating slow and time consuming. So, the sun's heat will be a very slow process for making the tea. Whereas, the stove converts the chemical energy stored in fuels into heat energy. When we keep the tea, when we keep the vessel of tea on the stove, what will happen? The stove contains all fuels. What happens when we light it, when we burn the stove? It will convert all chemical energy stored in fuels into heat energy, and the heat will be generated rapidly, that is fast. So, this energy generated is transferred to vessel in large amounts. Hence, the tea made by Shivani using a stove will be ready first. So, students, is it clear? Solar cooker uses heat energy generated in the sun. So the sun is very far away from the earth. So very little amount of heat reaches the earth. It's a very time consuming process and a very slow process. And on the other hand, the stove converts the chemical energy stored in the fuels into heat energy. It's a rapid process. So the tea made by Shivani using a stove will be ready first. Moving to the next question, question number 4. It's a numerical. What must be the temperature in Fahrenheit so that it will be twice its value in Celsius? So, solution. What are the given things? Temperature in Fahrenheit, where F is equals to twice the temperature in Celsius, which is Celsius is denoted by capital C. That is, from the sentence, we come to know that F is equals to twice C. So therefore, C equals to F divided by 2. Now what to find? To find temperature in Fahrenheit. What's the formula? We know, students, we have learned the formula. F minus 32 divided by 9 is equals to C divided by 5. So just calculating. What will be the calculation? Substituting from C in formula. We will substitute the value of C, which we have came to know that C is equals to F divided by 2. So let's substitute the value of C in the formula. First, the formula is F minus 32 divided by 9 is equals to C divided by 5. So F minus 32 divided by 9 remains as it is, which equals to, in place of C, we will write F divided by 2 multiplied by 5. So now, after substituting, all mathematical calculation comes. When we multiply, 2 multiplied by 5 gives you 10, and F minus 32 remains as it is. And cross multiplication, doing the cross multiplication, 9 multiplied by F gives you 9F. So when we solve the bracket, 10 multiplied by F equals to 10F. Sign is minus, so we will write as minus, and 10 multiplied by 32 gives you 320, which is equals to 9F. Afterwards, taking the coefficient terms one side and variable term one side. When 10F, what will happen then? 10F, when plus 9F comes to the LHS side, it will become as minus NF. So 10F minus NF, 9F gives you 1F, means F, and minus 32, when it will goes to RHS side, it will change its sign as plus. So what we got the answer as F is equals to 320 degree Fahrenheit. So student, this is the required temperature in Fahrenheit. Moving to the next question, question number 5. Write brief answers. First one, describe a clinical thermometer. How does it differ from the thermometer used in laboratory? So students, in this lesson number 14, we have learned about different thermometer. So in this question, we have to describe a clinical thermometer and how a clinical thermometer is different from a laboratory thermometer. So, answer. Point 1. A clinical thermometer consists of a narrow glass tube having a bulb at one end. So, a bulb is at one end and its shape is a narrow and it's a glass tube. Second point. The part of the tube along with the bulb filled with mercury or alcohol. So, the tube which have bulb, it's filled with mercury or alcohol. As mercury is harmful to health, alcohol is preferred. So students, in the olden days, mercury was filled, but nowadays, mercury is harmful to health. Alcohol is preferred the most. Third one, the rest of the tube is evacuated and the other end of the tube is closed. Evacuated means it's empty. So, fourth one, the bulb is kept in contact with the body of a person whose body temperature is to be measured. The bulb is touched to the body whose temperature have to be checked. So thus the temperature of the bulb becomes same as that of the body of the person. When we touch the bulb to the temperature to the body whose temperature we have to know, what happens? The bulb absorbs all the temperature from the body. If the body temperature is high, because of the increased temperature, the alcohol inside the tube expands. When the bulb detects that the body temperature is high, what happens? The alcohol inside the tube expands, means it rises, and it rises in the tube. The body temperature can be obtained from the level of the alcohol inside the tube. So, what will be the rise in the alcohol liquid present inside the tube? That will tell you the body temperature. Fourth point. Sixth point. As the clinical thermometer is mainly used to measure body temperature, the range of this thermometer is marked from 35 degrees Celsius and 42 degrees Celsius. So students, a clinical thermometer is used to measure the body temperature of the patient, or normally it is used as home also. So we know in degrees Celsius, the healthy person's normal body temperature is 37 degrees Celsius. So the thermometer ranges from 35 degrees Celsius to 42 degrees Celsius normally. Seventh point, the thermometer which is used in laboratories is constructed in similar manner, except that the thermometers in laboratory can measure temperatures ranging from 40 degrees Celsius to 110 degrees Celsius, or larger in some case. So students, why is it so? A clinical thermometer is used mostly to check the body temperature of human body. To check the body temperature, it means to check the temperature of human body. So the human body temperature range is, normal body temperature is 37 degrees Celsius. So its range is from 35 degrees Celsius to 42 degrees Celsius. And same how in a laboratory, we have to check the temperature higher than that. We would not know the temperature, what is going to range. So the only difference between the clinical thermometer and a laboratory thermometer, that is, it differs in their ranging property. The range in laboratory thermometer is higher than of clinical thermometer. It's of 40 degrees Celsius to 100 degrees Celsius, or larger also. Second one, what is the difference between heat and temperature? So, first point, the heat content in a substance is the total kinetic energy of the atoms in the substance. We know, student, when we have to measure heat, what we take the total kinetic energy of the atoms in that substance. Temperature, the temperature is measure of the average kinetic energy of the atoms in the substance. When we want to know the temperature, what we measure? We measure the average kinetic energy of the atoms in the substance. And in the case of heat, we measure the total kinetic energy of the atoms. Second one, heat content of any substance depends on the number of atoms present in it. Temperature, heat content of any substance does not depend on the number of atoms present in it. So students, what happens in heat? Heat content of any substance depends on the number of atoms present in it. And in the case of temperature, it does not depend on the number of atoms present in it. Third one, it is measured using calorimeter. We know, students, calorimeter is the apparatus which is used to measure the heat of an object. And in temperature, thermometer is an object, is a device which is used to measure the temperature. Fourth one, heat is measured in joules in SI system, while in calories in CGS system. So in temperature, the units of temperature are degree Celsius, Fahrenheit and Kelvin. So what are the units? Units of heat in SI unit system, it is measured in joules. And in CGS system, heat is measured in calories. And in temperature, in the case of temperature, the units of temperature are Celsius, Fahrenheit and Kelvin. So this was the basic and major difference between heat and temperature. Moving to the next question. Explain the construction of a calorimeter. Draw the necessary figure. So students, calorimeter is an apparatus used to measure heat of an object. So how it's constructed, how the calorimeter is made? So answer. A calorimeter is a device used to measure heat content of an object. Construction. First point. A calorimeter consists of two vessels similar to that of thermal flask. So students, it consists of two vessels which similar looks like as thermos flask. We know student what is the thermos flask. So the inner vessel is made of copper. Calorimeter consists of two vessels which is similar to the thermos flask. So the inner vessel is made of copper. Second one, the space between inner vessel and the outer vessel is filled with insulator like air. The air cavity is present between both the vessels. Both the vessels are connected to each other by a heat resistant ring so that no heat is transferred between the inner vessel and surrounding. So students, its construction is made very properly. It's constructed very accurately. Both the vessels are connected to each other by a heat resistant ring so that no heat is transferred between the inner vessel and surroundings. Thus, the inner vessel is thermally isolated from the surrounding. Due to the heat resistant ring, what happened? The inner vessel is thermally isolated from the surroundings. Third one, both the vessels have a single heat resistant lid fitted on top. So it's covered with a lid which is single heat resistant lid which is fitted on top. There are two holes made on the lid from which a thermometer and a stirrer are inserted in the inner vessel. The lid contains two holes from which a thermometer to measure the temperature and a stirrer to stir any liquid which we want to know the heat content is inserted in the inner vessel. Fourth one, thermometer is used to record the temperature of the liquid and stirrer is used for stirring the liquid. So student, this is how the construction of a calorimeter is made, which is used to measure the heat content of an object. Let's have a look on the diagram. Let's understand the diagram. Here you can see students. Here are two flasks. You can see two vessels with similar like thermos flask, outer vessel and inner vessel. You can see the air space between which is working like an insulator in between the inner vessel and the outer vessel. Upper side you can see a lid which is insulated lid. Here the insulated lid contains two holes from the one hole a thermometer is placed and from the other a stirrer is placed. Thermometer is for the measuring temperature of the liquid and the stirrer is for stirring the liquid. An insulated ring. So students, this is how the calorimeter is. So students, we have completed the revision of lesson number 14, which was measurement and effects of heat. Thank you my dear students. Revise it thoroughly. Learn the question answers properly. To get your more concepts clear, watch the video repeatedly. Till then, have a good day.